Thanks, Eric. I hope I'm audible and it's clear.
It's audible, but not too loud. But
Okay. Is it better now?
no, I think you have to sit close to the laptop. I think that the kind of microphones are not working. They use the microphone.
Is this better?
Yeah, I think that's okay. Yeah.
Okay. Right. So, welcome all, and hello to everybody who are attending, and even the panelists. So, this is a case that I wanted to discuss this time in the conference. And it's a practical case. We will go in detail as to what we looked into during development of a product. So at CGI, like how Eric explained, that we have an estimation center, and we are a good, strong team members we have in estimation center, where we work with proposals. We help team in estimating their projects if required. If certain projects are turning red, we look into it. We validate the estimates. We also train projects on how to do better estimates. We also train people on to how to do better sizing, what kind of sizing, what approaches, what methods. We even collect data. We also train various accounts and teams how to do the data collection, how to do the statistical analysis. So I think whatever is close to our heart over here, or to all the panelists and attendees, and that is where I think everybody is trying to do the same into their organization or into their consultancy if they are owning the consultancy. So to start with, and we started to where Eric is also involved. So he does the tough part. He goes and get the budget to build a global estimation application. So after having a huge number of expertise in estimation center, and we were able to convince the management that we would need a global estimation application. And you can see that what we are trying to cover. So we are trying to cover the solutions that come to the projects, and the activities with which they participate into the solution, which turns into projects. The effort estimates they do, and it could be the variety of effort estimates. So we are going to support those varieties, collect the metrics at the end. So the project teams should be able to collect the metrics rather than we going behind them to collect the metrics. It should be an automated process. They should be able to collect the metrics account-wise, BU-wise. So we are looking at a global application covering the complete vertical and the horizontal of our system. Also enabling the resourcing, costing, scheduling. So all the things that is required for a project to run successfully, as a kind of a one-stop place where people can do things, find things, take reports, again come back, look at the forecast, even validate their estimates. So all possibilities should be there. So it's a kind of a large product that we are building. And as part of estimation center, you would imagine that we have to also own the credibility that if we are estimating for this product, it would be right because estimation center has estimated. So this is, I'm just giving you this storyline, that this is the storyline on which my case study is built. And the importance is, like, what I'm trying to say is something I'll conclude on later. So when we started this estimation application, we looked at that it should be based on microservices. And we defined that what could be the microservices. So each modules that we think that it can exist independently, it can be owned independently, it can be developed independently, and that becomes a microservice. And these modules, even existing independently, it can be exposed to other applications also independently. So when we look at looking at an application, we are looking at a kind of a modular approach that if I want to get into the estimation part, I can see that many teams or many accounts, they have their own estimation methods, or probably they are having their own estimation application. So how can we integrate with that? So that is why we went with this certain approach. So I'm not going to discuss the strategy of the application here, but I'm giving a view because it will be helpful as I proceed into the case study. And then also the integration with other like Jira and the CAST system, where we are reading the code quality and CAST is generating the reports. So how do we pull in those reports? Jira again. So these are certain aspects that we were looking at. And that's when we thought that, okay, let's go with the microservices because this kind of architecture is going to help us. So we will go ahead. Kind of a view so that we establish the context. So we could have also developed a monolithic. It would have given us the same functionality, but only that integration that we wanted with other applications, so that we are able to take advantage of other application that is already running into the system, and that should be an easy integration rather than we again run the wheel and make the same thing again into our own application. So then that is the difference, what we see over here, like monolithic versus the microservices, where from the front end, they both will look the same because for the user, it doesn't matter. We are accessing the same application. But inside, actually, it becomes different applications altogether because they are existing independently. And there are a lot of API communications that is happening. So this is mostly the technical details of the architecture itself. With the advantages that we got with microservices, it was huge. So it was helping us into independent development. It means that if I have 4 to 5 developers and you have seen that what is in our mind, we are going behind solution, we are going behind reports, we are going behind estimates. So if we have different functionalities, probably different developers can take up on those functionalities and parallelly develop. So in that case, our schedule should come down and we would be able to deploy the minimum viable product earlier rather than taking a lot of time and installing the whole code base together after a few years. So these aspects of independent deployment, independent development, and like even the mixed technology stack, like even if we have built in Java and there are other product available in .NET, we are able to extend our microservices to other product and communicate with the other product. So these advantages led us to believe into the microservices that it is going to be the right architecture, and we went ahead with that architecture. So now the case starts. This is a complete new development. We don't have any baseline anywhere. Like in our expertise also, we have sized many applications, we have sized many products, estimated many projects. But this kind of application generally does not exist. We work on more like a business type of application. So this was a full conceptual application and we followed the agile life cycle. We had already completed 18 months of development and another 6 months to go. There was a bit of stopgap because of COVID-19 that came in, and by the time we had already moved our code into the production as a minimum viable product. So that was a very good aspect. It is being used right now. But there was another 6 months of the functionality to be delivered. And with COVID-19, we got some time to look back and think that how much of scope we can still cover. So, and then management wanted to understand that are we on track with respect to cost and schedule. So Eric had to answer that yes, we are fine on the budget, or do we need some more budget to cover the scope? So we started to do this cost estimation process, and since it was already we had done the estimate, and we are the estimation center, so we would apply the ISO norms, where we went ahead with applying the quick function point approach. This is a approach which is compliant with IFPUG and Nesma function points. And then we also went ahead and got the data from the team, that how much of actual effort that they have put into this project. So we got that data, and we verified. The third step was that we are going to verify it with the ISBSG dataset using the tool of Galorath, which is CRSM. So that is also integrated into our application environment, so that we give the projects the access to do a parametric estimate, and they are capable enough to do a reasonable estimate themselves. And later we would be publishing the results. So this is the background of the case that I'm going to come up with now. So applying the quick function point, this is the method. In during the ISMA 13 conference, I had already shown the method, how it works. It works on the proxies, but these proxies are typically dependent on the technology. So if I have a SAP application, or if I have a data warehouse application, the set of proxies will change. But this is a generic list of proxies which work. If a certain FP expert is working, they would be able to work out with this certain set of proxies. The results of QFP is very promising, and after having many projects validated through this QFP in our organization, we work with this quick function point approach, because the variation is not more than 8 to 10% when we do a real IFPUG or an Nesma count. So we went ahead with that, with this approach of sizing. And to look at the sizing approach, the whole estimation environment, where I showed you the microservices concept. And when the sizing expert came in, I'm also a function point sizing expert. So when the sizing expert came in, the sizing expert looked from the user's point of view, definitely. So went on, logged into the application and say that, okay, I see these functionalities. And out came with a certain size result. So with the size, we performed the effort estimates. Front end has a high complexity, because you can see that if we are working with all that solution estimate reports, there has to be a kind of an intuitive UX designs. So it is on a higher complexity, and even the security levels are high, because we are dealing with the project and the account costing, their resourcing, their estimates. So they would try to maintain that data confidentiality within themselves. So it has got these two extra high parameters, and we collected the actuals data from the team. But the result was very alarming. The size estimate that we received, and through that, the effort estimate that we received, is quite different from the actuals that was coming from the team. This gave us a kind of a option that we will have to do a further investigation before we start another 6 months of the project, because then we have to talk about the scope, that how much budget more will be required for the scope that we have. So we plotted, we tried to see that where does it fall. So it is in the plus minus sigma, and it is actually quite close to the trend line. So there is not an issue. So it seems that the size, effort, everything looks to be in the right direction, but then the development team has taken more effort. So what is the reason behind it? So we went on with one by one approach to start ticking off that if we have covered this, and doing a kind of an elimination that if something wrong is somewhere which we have to find out. Now the onus becomes more because we are from the estimation center, so we have to be right, and whatever we do has to be perfect. So there is more accountability over there. So when we went on to the actuals and effort and schedule report by the team, I'm also one of the product owners. So we found that, yes, the effort was really spent. We had seen in day in and day out. So according to the effort, what has been reported, that looks to be reasonable. And even the way to the activities, the time was booked was the reasonable. So only one area was something that we had to look into, is that did we miss any requirements while we were sizing, because the sizing becomes really a key parameter for the estimate. So did we miss something over there? And then I remembered Saurabh is also on this call. So during ISMA 17, Saurabh had made a presentation on the microservices, and the difference of effort that he and his team had found, and due to that he presented that what was the differences. So I had a kind of lead over there that probably it's the microservices, and it is a kind of an architecture which is leading to the difference. So from the size, if I see from the user's point of view, for the application, it doesn't matter because I am using all the functionalities of the application. But inside the communications that is happening, the performance that it is giving, they are the major differentiator. So we had to look into this microservices further to find out about this gap. On the microservices, so the important aspect was that each microservices becomes a standalone application in itself. It has its own database, and it interacts with other applications independently. So these are the three findings that we had with the architects. Plus, we also read few publications like IBM and certain more publications to find out that why microservices become really different than the monolithic. So now this is the game changer. The application boundaries change. We were working with one boundary. Now suddenly we have 6 boundaries over here. Naturally now there is a big change. Each microservice is recognizing the other as an other application. So our interface files are changing. There are more external interface file now in play. The transaction size on the transaction, the complexity has changed because there are more FTRs referenced. The communication has increased. So there is an overall, like if you can see 35% due to the data size and 20% on transactions. So overall there is a 21% increase in the size itself. The system complexity remains the same because the front end is anyway the front end, and it has high complexity, and security requirements is also high. Now, after this, when we run the estimates, the estimation tool with this particular size input, there is only a 2% difference found between actuals and what we estimated through this revised size, which gives us a kind of certain thoughts about the architecture itself and how independent a size could be. So if you can see in this particular graph, this was the initial estimate, since it's a logarithmic scale. So this was an initial estimate, and this is the final estimate that we had. It is still within plus minus 1 sigma, but then there are less data points over here. And so what we now know is that what the team had taken actually is the right one. And this this is going to conclude something that as an expert, like when we are talking about a sizing expertise or estimation expertise, we have to also look on the upcoming architecture or upcoming technologies that are coming. It becomes very important because now the projects are dealing with it, and we have, if we are still with the same mode, it becomes problematic. There is certainly going to come a gap between the estimate and the actuals. So microservices based applications seems to be more complex than a monolithic architecture. Not many applications, not many projects are new development. Slowly, the projects are getting converted into microservices. So it's a slow process, but we have to look for more data points over here. The cost estimation of microservices based application, it requires definitely a different sizing approach. This also leads us to think that we have white papers for SAP, for middleware, for data warehouse, and it really would make sense that we also have certain things for microservices. Or somebody even raised a question in the questionnaire that if we have looked into the AI. So as sizing and estimation experts, I think we should be looking for those kind of areas as well, which is coming in, and trying to put some white papers, which is going to help the community at large. Like I could refer to Saurabh's presentation, and that could give me a kind of a confidence that, okay, it's not only me, but somebody else also faced it. So these conferences helps us to find out these kind of cases, and we can proceed with white papers and some publication with more data points. The applied sizing approach, what I have found, it is mainly impacting more on the data functions. The transaction functions complexity went up, but there is more impact on the data function. But this is, again, I would say it's a one data point in my view. We should collect more data points to really identify this impact. Now with this adjusted size and the complexity parameters that we identified, it is very comfortable, and my confidence level has increased that for the upcoming scope of the work, I would be able to happily and confidently determine what could be the estimated effort, and what scope is possible. Even if we go for the budget sessions, we would be confident that how much really we need to deliver the project successfully. The sizing of the microservices based applications, it requires further guidelines to achieve consistency. So probably we are a very large group over here in this conference, and we can definitely get in touch with each other and help to bring a white paper on this microservices. So this is from the case that, and it's a very recent as 1 month back, and I wanted to bring out in the conference to discuss about what goes on really when a product is being built, and how the sizing technique really helps into bringing the realistic cost estimate. So this was by end of my presentation, Eric. If there are any questions.
Okay, thanks, Bhawna. Yeah, there are some questions. I will try to combine the two questions. Is the question about what is what should be the impact? Is it okay? Should we focus on changing the sizing for microservices, or it is a question from Jolijn saying, okay, is development for microservices, is that less productive? And Babu mentioned, okay, should we focus on the difference in sizing or the difference in productivity? So what is your view on that?
I would say it's not the productivity, because now we are looking at the application boundary itself. If the application boundary is too large, then you would say yes, the productivity is less. But that's not what it is. Actually, microservices, it has its own database. So the way it is constructed, it's constructed like a application on its own. So even if we look at some large portfolios of the client that we deal with, there are many small applications, and we treat them as separate applications because they are delivering a certain functionality. They are able to communicate on their own. So that is where the application boundary has come in place. So we should have a separate application boundary for each microservice. It doesn't give a productivity impact. Productivity still remains the same. It is language specific productivity. So that is still gives us a good realistic estimates, unless the parameters like requirements changes or the security levels, they are different, then only the productivity is impacted.
Okay, thanks, Bhawna. Because of time, I will not continue with the questions. There are some other questions on the Q&A. If you can respond on that, if not answered yet, or otherwise you can answer that. They're answered live. So we will go for a short break.